Okay, so as promised, I'm going to show a little video here of how to create a normalized scattergram using homofret imaging data. Okay, so I just have a typical example here. This is the one that was actually used in the paper. I'm going to open up these two images in image J just so you can see how this looks. Okay, so this is number 000. This is the image collected when the polarization on the input and the output is parallel, and this is the image when the polarization input and the output are perpendicular. Now I'm just going to put those into a stack so you can actually see that there is an intensity difference here. Okay, I'm just going to auto contrast this. Okay, this is way blown up, more than normal, but you get the point. And it's actually put the images in the wrong order. But anyways, there they are. So I'm going to close those up. First thing to do is to install the plugin. And actually it's a macro. That's the correct technical term here. And as you can see, I have many different versions of this, and the one that I'm currently using, and the one that was most accurate, is version 18, and this is 532 nanometer excitation, so that's the one we're going to use. So install it, one macro installed, it says up here. Okay, now we're going to run the macro. So just start it up, and then you got to find those files. Okay, so they're on my desktop. Please ignore my very messy desktop. And here I just have a copy. Okay, so there they are, the same two image files. Click choose, and voila. Okay, the macro has started. So first thing we got to do is isolate the part of the image that actually is a cell. Okay, so what I'm going to do, there you can see it again if I pull the threshold down. I basically want the red area to just cover the cell. Now obviously this would be too much, or because I've clearly got background area, this would be too little. Okay, so somewhere about here. Now this is a bit arbitrary, right? There is a human element in this. If anybody wants to automate this, please go ahead. Of course, right, so the edges are always going to be an issue here, and you have to be aware of that. Okay. Also, just take note over here, my histogram is showing that I have the maximum value, 2 to the 16, 65,535. That means that some pixels are saturating at this moment. I don't want to include those. Okay, so if you've collected images and you have saturated pixels, just knock this down once or twice. There you can see a few white pixels right there. Those are saturated pixels. Okay, so we've excluded the background, we've excluded saturated pixels. Okay, click apply on the threshold window, voila, and then click OK over here. Okay, and some magic happens. There's my wonderful anisotropy image. Okay, it's been auto scaled. We can look at this in a histogram. Histogram, I like using the range minus 0.05 to 0.45, and there you can see the histogram. Okay, whatever you do when you present an image in a paper, just make sure that the color scale, i.e. the contrast for the image and the contrast for the histogram, are the same. Okay, that's very important. Otherwise, this histogram does not reflect what's here in the image. Okay, so I'm going to close these up, and we can now look at what happened. The plugin, the macro, automatically created the anisotropy image, and it also created the total intensity image. Now, the total intensity image, if I pull up, sorry, that's not it. Let me just pull up my thesis, which is nowhere to be found here. Let's go back to the desktop, and it should be here somewhere. Thesis, and here we go. Alright, so what I'm trying to say here is, yeah, right here, the total intensity is the denominator of equation 47 here. Okay, it's important that we include basically the sum of these two factors, and this multiplication of 2 is important. And of course, as you know, my thesis was all about including the corrections for high NA, these so-called correction coefficients, which were created by Dan Axelrod. There they are in their glorious form. And what's important here, and of course this is the wrong version, this is the old draft where there was a mistake, but what I'm trying to say is, you notice when I wrote equation 57 here, I included the top and the bottom, the numerator and the denominator, before canceling out this common factor. So the total intensity is really this whole thing here on the bottom of equation 57. Okay, and that's what's being calculated, and we're going to use that for the normalization. Okay, so I'm going to close that up. And again, just bear in mind, this isn't the correct version. There's an error right here, and a few of these factors are mixed up. Go to the one on the website. That's the correct version. It's almost identical. Okay? Right, so what's next? Now we want to open up Igor Pro. Sorry, no, we want to go back there. There's one other thing I need to do. We need to take the data which is in the image and convert that into a format that Igor Pro can read. So that means I need to take the pixel data and transform it into a column of data, basically. So let me just open these up again. And there's our anisotropy image, which I always like to view in the Royal lookup table. And just reset that there. And again, as I was talking about the corrected total intensity image, okay, what we're going to do is basically ask, I'm going to have ImageJ run another macro, which I've given to you guys before, which goes along and takes each pixel from these pair of images and pulls them out into a table of data with two columns. So we'll take pixel 1 over here in this image, and pixel 1 over here in this image, throw them into a column. Then we're going to go to the next one and do the same thing, and so on and so on and so on, until we've transformed all the data in these two images into one or two long columns, okay, which contain all the information. I'm transforming a two-dimensional image into two one-dimensional long columns, okay? So what I got to do is install another plugin. This is the one that I've given you before. Now I have no idea where this one is. Here it is. Okay, FPM, fluorescence polymerization microscopy, plot anisotropy versus total intensity. Okay, so version 3 is the most accurate one, and let's just install that. Okay, and so it should be installed, macros, there it is. Okay, I'm going to run it. Choose the file folder where the data is contained. It's the same one. Okay, and bam, there, it's done. It did it. Okay, so now when we go into that same file folder, now you see a text file, anisotropy versus total intensity .text. Okay, so there it is, and you can open it up, and you'll see that there are a lot of pixels that are NaN. Those were the ones, not a number. Those are the ones that we thresholded to 0 in the total intensity image. Okay, and there's all the data there. Okay, now I'm going to stop this video here because I'm worried that it might be getting a little too large at this point, but I will continue it in a second video, okay, which will show you the next part, all the stuff that we do in Igor Pro. Okay, so stay tuned, and I'll be right back.